Well, hello again for many of you here. I'm Tim Wagner for any of you joining us in this session. I'm the general manager for both Lambda and API Gateway. And joining me here on stage today is Rory Jacob. He's one of the developers on the Lambda team. He's going to be helping me out with some of the cool demos for some of the new features we want to show you today. Now, if you heard Werner's keynote or my State of the Union address, you already know about some of the new things that we're doing with Lambda and with API Gateway. In this session, we're going to go into a little more detail and show you some of the demos of things like SAM and DLQ to give you better insight and deeper insight into how they work. Let's see if I can advance here. Alrighty. So we're not going to cover too much in this session about the Lambda basics. So I'm going to presume most of you know what Lambda is and what we use it for. Scalable, serverless compute in the cloud. I do want to quickly, however, frame where we've made these new investments and why. So we think about the capabilities of a serverless platform as kind of these 9 different categories. The core logic, things like Lambda and event processing, orchestration and state management, how you can build and orchestrate an entire application together, how we hook up data sources and make them responsive and flexible together, how we model those applications, how we talk about the different pieces that compose them, the broader developer ecosystem that Lambda sits in, not just AWS, but also third parties and open source, integrations, monetization, and marketplaces, security and access control, reliability and performance, and then global scale. And increasingly, global in every sense of the word, not just including data centers. So let's go ahead and get started. Let's see this one. All right. So the first thing I want to tell you about here today is CI/CD for serverless apps. We're going to talk about some of the new features. I'm going to tell you a little more detail about SAM, the serverless application model, and in particular how SAM gets used in both CloudFormation and in building those pipelines to do the package and deployment operations that let your serverless apps get built with increasing ease. And then we'll talk a little bit about how code build helps make that job in particular of packaging, especially Node and Python apps, much easier by being able to supply third-party libraries for you. But before we do that, I want to make sure everybody heard the news. Environment variables are here. So we brought this out a little early, a couple of weeks before reInvent. This has been our most requested customer feature. And we wanted to do it in a way that provided appropriate security, so fully integrated with KMS, allowing you to also bring your own keys if that's what you like to do. Also making it simple so you don't have to do that if you don't want to do it. And making sure that it plays really nicely with AWS Lambda's publishing mechanism. So that if you want to create immutable snapshots of your code, you can also create immutable snapshots of that code's configuration. So you can have reliable, trustworthy combinations of those two things together while still giving you the flexibility and the freedom to change either anytime you need to. So fully integrated with publishing, fully integrated with the versioning model. And of course, you can set environment variables in the console. You can, of course, do it programmatically. And accessing it in your code from any of the languages, including our new language, is just the standard mechanism for retrieving whatever the environment is in either Python, Node, or Java. Now let's move on and talk a little bit about SAM, the serverless application model. So as I described earlier in the State of the Union, SAM is a common language for describing the contents of a serverless app. And we've made CloudFormation speak SAM. So it's got native support built in for this new language. Now what actually happens is you can think of it almost like a macro processor. So it will take the SAM information and it will convert it into standard CloudFormation template speak. So all the things that CloudFormation can do today, all of the different kinds of deployments it can do, all the things that it can configure, all of that power is still accessible to you. There's no cliff here that you kind of fall over, but you get to model the serverless parts in a very simplified fashion, one that we can also use in a lot of other places, while still giving you access to all of the power of CloudFormation. And then we've added some command line tools that you'll see here to package and deploy Lambda-based apps as well. Now, you can also walk up to the Lambda console and point to any blueprint or any of your existing functions and say, give me a SAM for that thing. And based on the information that we have, we'll give you an exported SAM file that you can then go use and turn around and inject back again in a build cycle. So here's an example of a SAM file. This is a complete representation of a really simple serverless app. And it's got all the basics. It's got a function, it's got an API, and it's got a NoSQL data source. And you can see there in just a few lines that we're able to capture the content and composition and relationships that went into that simple serverless app. And if you're saying, well, that's no big deal, here's what that replaced. And this is one of the reasons that it's really important to have a model that's both human readable and comprehensible, like the one on the left, but also machine readable, so that not only AWS, but other companies and projects as well can interact with it. And that's the reason that we've also chosen to open source the specification for the serverless application model. So we have this Apache 2 licensed up there as a GitHub project in AWS Labs, and with the intent of being able to share that broadly with all of our ecosystem partners and avoid the problems and pitfalls of having everybody define this in a different way. So you can think of it as kind of defragging the modeling part of our serverless ecosystem and community. And so we're really excited to help do that as a way of accelerating and helping to power the community forward. Now with that, I'm going to turn things over to Rory. I'm going to start to take a look at how this actually works in practice.
Awesome. Thanks, Tim. My name is Rory. As Tim said, I am a engineer on the Lambda team. And if we just quickly switch over to my laptop, we will see Sam floating around over here. And I'm going to walk you through a little demo I made that kind of shows the combination of all the different pieces we've talked about at this whole presentation today, as well as the what's new or the State of the Union for serverless earlier, as well as the keynotes that have happened over the past couple days. So here we are. This is Sam floating around. He's pretty lonely. He's at reInvent, but he didn't really come with anyone, and he wants to have a better time. There's all these different events, so we essentially want to make sure that Sam has the friends he needs to enjoy his time at reInvent. So I have a website right here. I have a Lambda function which tells me how many friends he should have, and we'll kind of get into the other parts of it in a second. So the first thing we're going to do is take a look at the Lambda function, which is right here. Super simple Lambda function. All we do here is I'm taking this SAM count right here, and I'm taking this multiplier, which is using the environment variables we released about a week or two ago. And then we're taking this and we're multiplying them together and returning that value. So really, really simple function, all that it does. So for the time being, let's just change this. Let's say 17 seems like a better number. That's not too big that he can actually get a beer when he goes to the pub, but small enough that he has a good amount of people to kind of hang out with and enjoy himself. So we change this. Let's just make this change now. I'm going to add this change to my repo. So I'm using GitHub as my repository. You can use code commit, GitHub, all is the same. But for this demo, I'm going to use GitHub. I'm going to commit this change here. Say let's give Sam some friends. And push this. And now what's going to happen is this is going to go to my GitHub repository, and you'll see what happens in the future as we go through the different parts. So I have my Lambda function, which I just talked about, but what other parts do I need for this kind of whole demo? So I wanted to kind of write those out to give me a better idea of what parts of the serverless model and the serverless website I can use to build everything. So we need the website, right? The website that showed the floating SAM icon. So I need some sort of website. I'm using S3. So I'm using S3 for a static website to display display the party, essentially, right? The next step is I need that Lambda function that I just wrote and just updated to tell me how many people should be in this party. So I need a Lambda function. The next thing is I need an endpoint to call that invokes my Lambda function that gives me that data. So I need something, probably API gateway, and thankfully with the SAM template, I can define that whole thing. And we'll show how we're defining that in a second. So I need an API endpoint to invoke the function. And the very last thing is I have dependencies I'm taking into this function. I have a node module. I'll go over in a little bit, but I'm taking a node module called moment, which involves getting data information. I don't want to zip this up. I don't want to do anything with that. I just want to have a repo with my code, and I want something else to build this, package this, and deploy this for me. So I need some sort of building and package management. Build, package, and download, and zip. So that's what we're going to get to the code build part, and we'll get to that in a second. So for the API part over here, here is my SAM template. This is the only template that I wrote which generated essentially everything I needed from my API. I have at the very top here my function definition. I have my environment variables that I was talking about previously. I am taking that in as a parameter. And at the very end, I'm defining an event. This one being the API, and it's a get method. Now, before Tim showed you what the whole CloudFormation would make you do to create these things and link them all together. This does everything for me. So it creates my function, links my API, sets everything up so they're connected, and I have done literally nothing besides these 7 lines of code. And now that I've kind of gone through that, I think we have the different pieces here, and I'm going to bring it back to Tim. He's going to show you how this all kind of glues together, and then we're going to go back to what this happens with this party.
OK. We can flip back to computer 1 here. So this is what's going to happen conceptually now. We've set up a code pipeline that's going to be able to automatically detect and retrieve those changes that Rory pushed earlier. Right? So that's going to be extracted from GitHub. And then the new part is it's going to be able to hand it over to code build, our newly announced service today that's going to be able to do the packaging for us. So it's going to take that package, that library that Rory pointed out, moments, and automatically download that and include it. So that's functionality that comes prepackaged today in code build. Now, once we're there, we'll be able to do either npming, pipping. If it's Java, we could do the Java compilation. You could bring your own Docker. So you've got the support for building all the different kinds of languages and capabilities that you need. And then finally, once we've gotten all of that code set up, we'll package it into the form that Lambda recognizes. Same thing it uses today, sort of a zip file, fully elaborated with all the libraries. So it's got no module dependencies on anything else. It can run as a fully self-contained unit. And then we'll get to the final step here, where code pipeline will integrate with CloudFormation, hand over both the code and the SAM template, and then we'll see that go off and deploy and either build in the first place or update previously existing pieces. And those can include Lambda functions, APIs, data stores, and other pieces here. So I'm going to hand this back over to Rory, and we're going to go take a look at where we've gotten to in our pipeline here and see some of this in action.
Awesome. So let's go back to here, and let's go take a look at this pipeline. So here we are. This is code pipelines. All I'm defining here is I've created this before, and I have it pulling from a Git repository. Make sure this is coming up right.
There we go.
I have a Git repository I'm pulling from. You can see that it pulled the change automatically. I didn't do anything. I didn't tell it to pull things. It is pulling things as it is happening. The next step, there we go. The next step that's going to happen here is we're going to have it go to code build and actually build my source. So let's take a look at what that next step looks like. As I talked about earlier, I have this package.json, and here I've defined my dependency. I need this package called moment, and I need at least version 2.16. So Normally, you run npm install locally, you zip it up, you publish this whole package to Lambda. What I've actually done here is using code build, I can define this build spec. And what the build spec does is I have build steps that it runs in order, does whatever basically runs these commands, and then gives you an output artifact you can deploy. So here I have the first 2 steps. I have my npm install. Obviously, if you're using Python, this could be your requirements.txt, so your pip. And the next step that we do is this AWS CloudFormation package command, which is the new command that we introduced with the SAM template. And that takes your input SAM template, which in my case I called the SAML.yaml. You pass in an S3 bucket where you want to store the resulting the resulting combined artifact, and then you give it the name of the artifact you're going to output. So that is going to be your CloudFormation artifact, right? So that's all I've done. If we go back to CloudFormation here, we can see inside code build that it actually has run all the steps. It has run all the steps. It has taken everything, it has run my build steps, and it has given me that output artifact. And now if we go back to the pipeline, zoom out here. Yeah, 1 second. If we go back to here, I can see that Sam has some friends to play with. So essentially what we've just done is we've made the code change, we've built it, we've deployed it, and it's done all that for me inside the whole CD pipeline. And the next step is obviously, this is really cool. We haven't had this before, and this is an integration of the different parts. But I know this is reInvent, and I went to the pub crawl last night. I know this is not exactly what reInvent is like. So I'm going to go back to my function here. I'm going to refresh the page so it gets the newest version of the function. And I can see here's the code change that I made. So before I had it set to 1, and now instead I have it set to 17. So if I go down here to my SAM multiplier, get this up. I'm going to change this to 20. Let's say 20. Why not? Save this. And I go back to my page. And now this is more what it feels like to be at kind of the reInvents here. So that's kind of the combination of everything. We have the SAM template. We're using code build to actually build and package our application. We're using environment variables to allow for operational configuration. And we're kind of combining all this together, which is really important to have a really good serverless architecture. So now I'm going to pass this back to Tim. He's going to keep talking about new things.
Thanks. So what you saw there was a complete CI/CD experience from the code change all the way through to an update to what was, in this case, a simple serverless web app that was running. And then we followed that up with a configuration change. So illustrating the new environment variables and also showing the fact that the pieces of the serverless app haven't turned back into a monolith. So Rory was able to go in and change that environment variable, and we could update the application without having to do a complete deployment through the pipeline, although, of course, we can do that as well. So the benefits of the microservices, but still the simplicity and the capability of a complete entwined pipeline.
Yeah, yeah. It's like the refresh rate.
I want to point out a couple of other things here, just in case you missed it. Yeah. While not a Lambda feature per se, one of the things a lot of you have asked for is the ability to map more easily from CloudWatch metrics that indicate anomalous problems into logs. And so I'm really excited to point out one of the recent CloudWatch deliveries in the run-up to reInvent here, where in addition to percentiles, which we love at AWS and use all the time, they've also added a metrics to logs feature. So you can go in, find a metric that you think is suspicious or somehow anomalous, and then be able to hop directly to the CloudWatch logs that tell you in detail what happened. So you can utilize the metrics and the logs that Lambda's already generating and be able to tie them and correlate them together more easily as a diagnostic experience. So diagnostics in general. is a really important area for serverless apps and for Lambda apps in particular. And as we talked about earlier, we want to make this as transparent and simple a process as possible so that you can see what's happening under the covers and be able to find performance problems or other kinds of functional issues and then go diagnose them. And so I'm going to talk a little bit here about our new X-ray feature and some of the capabilities that it's going to introduce. So X-ray is designed to give you visibility into events as they travel from one service to another. So imagine a kind of a typical experience where you upload an object that triggers a Lambda function. Then maybe you have to call Dynamo to write some things into a database. Maybe you call some other services. All good until you start having a problem, like maybe that event didn't run when you thought it would. Or maybe you thought that it was processing 100 events a second, but you're only seeing 2 or 3. What do you do? So this is where X-ray comes in. You can think of it as essentially a cross-service, event-based profiling mechanism. It lets you trace calls and generate timing information from Lambda to other functions. And I've shown you here the configuration, which is super simple. With just a few lines of code either added or changed, we've been able to take this sample function and get it ready to roll with X-ray. This is the way it's going to be initially in preview. Our goal actually, when we get it to GA, is to actually have a complete zero-touch mechanism. So you won't have to actually change your code at all in order to be able to gain lots of insights from X-ray. Although, of course, you're welcome, and the idea is also that, as with metrics, you can always put as much custom logging or information in as you like. X-ray is launching in preview today, and Lambda support will be coming soon in the next few weeks. Now, one of the things you'll be able to do when we get there is draw a graphical representation of your service topology. And this is really exciting because each of these circles represents a piece of your application, and then the lines between them indicate the dependencies, indicate the event flow between the different parts. That can be one event, or one Lambda function calling another Lambda function. It can be an API backed by a Lambda function, or it could be another AWS service, ultimately, as we bring more online to support X-ray, that are able to send events to Lambda. And you'll be able to both see dependencies that maybe you weren't expecting, because we all know that sometimes in large production systems we find things we don't suspect, but also detect places where maybe throttling is happening, so that you can find the choke point on an event and trace it back to the origin and the source. Once you've figured out on this service map where the problem is, then you can drill in and get detailed information that helps you figure out, am I experiencing long dwell times? Am I calling another service that's being slow? Am I retrying more times than I expected? All of that information that today is a little bit opaque and harder to pull out of the system becomes very visible and simple to understand with X-ray. So we're really excited about this. We think it's going to be a great new diagnostic capability for the system, and we're looking forward to having that in your hands in the next several weeks. Now, I want to talk about a few additional Lambda features that we're launching today. The first one of these is for our Kinesis users, and it's a new Kinesis iterator type. Now, we've always given you the ability to start at the beginning of a stream and to start at the end of a stream. Today, we're also giving you the ability to start anywhere you want in the middle of a stream. At timestamp is not just another iterator type. It's also really important because it gives you some great new capabilities. You can disable the stream and then come back and enable it again, picking up exactly where you left off. You can also decide to essentially roll forward or backwards if there's some events in there that you don't need to read. So it's a much more flexible mechanism for positioning and placing yourself within streaming data. So we're really excited about that. You heard earlier in the keynote, most likely, about our new language edition today. So we're bringing C# in the form of .NET Core to Lambda. And we have lots of enterprises that use C#. And as a guy with a historical relationship to C#, I'm very well aware that there are a lot of people who love that language and who have been asking us to bring the power and flexibility of Lambda and C# together. Now, in doing this, we've tried to retain the best of both worlds. Just like Java, we've made it really easy to run C# functions and code inside of Lambda without having to make changes to them. We provide you with the same kind of metrics and logging capability you're used to in all the rest of our languages. Just as with Java, we'll make it really easy to serialize and deserialize typical AWS events. So S3 events will fit very naturally into this. And we've integrated this with Visual Studio. So C# developers who are used to living in that IDE and that environment will have an easy, fast, fun, and idiomatically conventional way of writing and deploying their code. Now, as you might have heard me say earlier, one of the things that we've heard from lots of our customers is that they need a way to create completely reliable end-to-end processing when they're doing asynchronous events. Either because they don't want to lose something, maybe they uploaded an object and they need to ensure that it's been processed, or maybe the content of the event itself represents information that they don't have stored someplace. And without a highly reliable mechanism, they have to create duplicate copies, or they have to have a second channel for that information, meaning that their serverless architecture might not be as simple as it could otherwise be. So we're really excited today to introduce dead letter queues support for Lambda. And the way this works is that, yeah, we're excited too. It's super easy to configure. You basically just tell us, here's the ARN of an SQS queue or an SNS topic. And anytime we're not able to get your event successfully processed through your code, so we don't get a successful return from it, we'll send it to either that queue or that topic for you to take action on it. And you can set these up per function. So you can have different queues or different topics per Lambda function. Works for all async invokes, regardless of where that event comes from. And if there's any problem in your configuration, as a fallback, we'll also issue you a CloudWatch metric. So as a kind of ultimate backstop, if anything's wrong in your configuration, you'll at least know that you need to go take a look at that in order to repair your DLQ setup and config. Now, we're going to take a little look here at DLQ in action. So what Rory's going to come join me on stage here again, and we're going to look at a really simple DLQ setup. We're going to simulate some S3 events coming into a Lambda function, only the Lambda function isn't going to behave well. It's not going to be able to process those events. And as a result, what it's going to do is send them to a DLQ, in this case in the form of SNS, and we're actually going to route that to another Lambda function to take some action. So Rory's going to step us through this architecture in the code.
Perfect. Thanks, Tim. Yeah, with everything that we've done here with asynchronous, DLQ, this example, we're going to kind of go over how DLQ is useful for those error scenarios we were talking about and see what do you actually get out of DLQ. So for me, I have a super simple function. Obviously, this is just an example, but you can have any kind of asynchronous event, have a DLQ hooked up to some sort of have a DLQ that you push to some sort of recovery function. So we'll kind of go through the details on that. The first one here, we have a function. It's very, very simple. All I'm doing in this function is I'm getting a bucket, I am getting a key, and I'm trying to get that object from S3. So very simple. And when I get the object, I'm just returning the content of that object. Obviously, here I have this exception where I'm printing the exception. I'm having this other error that I'm printing out, and then I'm re-raising that exception. And the main part to notice is that if this is an S3 no bucket or the object doesn't exist, that is the error that I'm re-raising here. And then you'll see that this is actually the error that we are able to get inside our DLQ and kind of work through that. So in this configuration, in the back here, under Advanced Settings, there's this area over here called DLQ Settings. And I've picked a DLQ resource for an SNS topic, and specifically called DLQ Demo, which I've just defined right here. Simple topic. I've subscribed, in this scenario, a Lambda function. And what this Lambda function will do is it will write to CloudWatch logs the error. So obviously, this is a very small example. Just writing to logs so I know and can recover from this. But you can imagine doing things that are much bigger with that. You can put that into a database. You can keep track of the errors. You can even do things like auto recovery based on certain scenarios. So there's a lot of different cool things you can do with DLQ. In this example, we're just going to write to CloudWatch. So here's the result. I'm taking this message. This is the payload that caused the error. So this is actually the invoke payload into my asynchronous event. Here is this message attribute, which will actually contain the error that was received, or that was thrown by the invoke. And I'm just outputting that as CloudWatch logs. So we go to CloudWatch right now. I've been kind of invoking this a little bit in the background, so we'll just wait for this to come out. But in a second, we'll actually see that the CloudWatch logs will display all those different areas. So we can even go, oh, here we go. Let me reload this. Give it a second for, there we go. So in this here, we can see my request. I have inside there the request ID, so I can track it down if I'm using an SDK, track it to the actual request the client made. I have the error type. 200 is what we throw if your function itself errors. And here is the actual error message that my function threw. So I'm saying that there's no bucket that exists. And in the next part here, I can see what the payload was that caused that to happen. So now I have all the pieces to essentially figure out what happened with my asynchronous invoke.
Great. Thanks, Rory. So if we flip back here, I'm going to just give you kind of a quick picture of what we just looked at there. So this is an illustration of sort of that DLQ architecture where his original function was generating failed events. We passed them to SNS, and then we published them into another function, which in this case was acting as our error handler. And two kind of things to note here. First of all, because those events can be super important to you, we have absolute payload fidelity. So all the bits that came into your original async invoke make it out to the DLQ. So you haven't lost any information. There's no lossiness. And you also saw there the other thing that we do, which is we give you these sidecars. So we provide some metadata that says, to the best of our knowledge, what failed and why, so that you have an opportunity to go figure out, was it a bad input? Was it an uncaught exception that you had? Not the whole level of diagnostic capability that something like X-ray will give you, but hopefully enough information as part of that payload parcel that you'll be able to see and detect what the actual problem was. Now I want to make sure we're kind of all caught up in some of the many integrations. As all of you know, I'm sure, Lambda is integrated with lots of other parts of the AWS portfolio, either events that can send to it or customization and extensibility like we do with Cognito and AWS Config. But a few that have happened recently, and there have been so many of them, I want to make sure that we're all on the same page. So just in case you missed it, Amazon Aurora has now added SQL triggers using Lambda functions. So stored procedures in the cloud in the form of Lambda. We've also recently implemented what we call the pass-through mode for API Gateway. So if you just need an HTTP endpoint on top of a Lambda function, we've made that really easy. Very transparent. You don't have to set up mapping templates. You don't have to set up lots of different endpoints. We'll just pass everything through to your Lambda function. And then what we've done with that is also launched an Express wrapper as an open source project. So in case you like using Express and you want to write web apps in Lambda, we've made that super simple to do on top of the pass-through mode functionality. Now, just in the last week or so, Mobile Hub has launched enterprise connectors that are built using Lambda functions. So if you want to create mobile apps, in fact, it's not even limited to mobile. If you want to create any apps that use these connectors to go out to, for example, Salesforce, you now have a really easy way to do that. And those enterprise connectors, you should imagine we're going to continue adding to that set there to provide you with broader capability. And finally, S3 has launched CloudTrail events on a per-object basis. Super important feature for those of you who use S3, and lots of different things that you can do with it, lots of important auditing applications. But I thought I'd point out one that has particular interest to Lambda users, which is that it effectively also now lets you respond to GET events on S3. So if you need to do some kind of custom audit traces or take other actions when objects are being retrieved, you can now do that on S3. Now, I mentioned in passing here web app frameworks. And we've been doing a lot of investment, as has the community around us, in making Lambda easier to use for building serverless web apps. Lots of great reasons for this. The scale down to 0, the instant ability to burst up to high levels of traffic make it really simple as a topology and an architectural approach. But until recently, one of the challenges was being able to use some of those frameworks that you're used to. So with things like Chalice and our Express open source projects from AWS, and with open source offerings from Claudia.js and others, you can now find mechanisms out there to do Flask, WSGI, Express, ASP.NET Core, and others. And so we're really excited about this, helping people build web apps faster and simpler without having to give up the part of the frameworks that they love, but still gaining all the benefits of a serverless approach. Now, one of the really nice things about Lambda is how stateless those functions are. You essentially are corralled into doing a great design approach where your code and your code and your storage live separately. And that works out really well for lots of things, especially places where it's a kind of a one-to-one binding. You upload an object to S3 and you run some code. You put a record into Kinesis and you run some code. You change something in Dynamo and you run some code. But what happens if you need to choreograph multiple functions? Maybe you upload an object to S3 and you want to do 10 different transforms on that object, wait till they all finish, and then send a message out via SNS to indicate that they're done. Well, that gets a little harder if every one of those functions is stateless. It's tough for them to watch the other functions. You don't want all of them to have to kind of do some complicated distributed timer. It gets a little bit more tricky to build an application that has that level of choreography in it. And so when you have these more elaborate mechanisms that you need in order to order functions together or choreograph their activity, that's where AWS Step Functions comes in. It's a mechanism to reliably orchestrate, well, lots of things in the cloud, but particularly multiple Lambda functions. So for example, maybe you've got a function and you want to run it more than our stock 3 times. Now with a relatively simple loop inside of AWS Step Functions, you can trigger that function multiple times until you've decided that it's accomplished whatever you were hoping it would do. Or you might want to take action in an event handler, and then regardless of what happened, even if your function failed, execute a callback that can do something when that's finished, essentially building a try-catch handler around an event processing function. There also might be situations where you need to wait. So you can't have a Lambda function sit there all day long, waiting for something to happen, but you can run a step function. And step functions can go for hours, days, weeks, months, for as long as you need them to. So you can repeatedly trigger a function, in fact, several functions, in order to choreograph a larger workflow that can span more time. And now I'm going to ask Rory to join me one last time here. We're going to take a look at one of these examples in particular, the one where we want to be able to take an image and do multiple kinds of transforms to it at once.
Awesome. Thanks, Tim. So as Tim said, I'm going to go through a super simple demo of taking step functions. And in my example, all I'm doing is I'm going to convert this image. This is a picture I took this past summer when I took a trip to Barcelona. This is the Sagrada Familia. If you know anything about this church, it is crazy old. It's been being built for like 120 years, and there's still like 20 or 30 years left. But it is amazing. But what I want is I have this in a JPEG format. I want it in, you can resize it, you can do a bunch of stuff. I just want it in a PNG and BMP. Let's just say that's what I want to do for this example. So I've actually already placed this into an S3 bucket. I have my file here. The bucket's aptly named Serverless Step Function Demo. And then if we go to my workflow, this is one that's already executed, but this is the workflow in itself, the graphical representation of what my workflow will do. So I see I have a start, I am setting up for these 3 different conversions. So I'm going to convert to PNG, JPEG. I already have JPEG, but let's say I didn't necessarily have it in JPEG, and BMP. And then the important thing is these actual conversion functions are actually just the same function, but it's being passed different values. So inside these setup functions, I'm injecting into it, I need to convert it to PNG. I need to convert it to JPEG. I need to convert it to BMP. So my function in itself is the exact same. The state before it actually defines what is happening. So let's take a look at and start a new execution. So all I have to do here is click New Execution. I have an input that I can pass into it. I've already practiced and obviously set this up, so you don't have to worry about me remembering what everything is called. And I can just paste it in here. In this scenario, I have a source bucket, which is the bucket I showed you, the image key, which is the image key that I also showed you, and the operation, which is the convert operation. So let us start this execution and see what happens in this scenario. So here, you can see it's already starting to light up. Let me zoom this in a little bit more. And here, as we start going through the execution, you'll start seeing that these things go green, indicating that they have finished. So already the JPEG conversion and the BMP conversion is finished. So if I go to this S3 console here, zoom out, and refresh the page, you will start seeing that these things are appearing immediately, happening in parallel. Go back here. This should show in a second that the PNG finished. Perfect, PNG has finished. Go back to the console page for the S3 bucket, and I can see that all 3 image conversions are here. I can even open an image if I so please. And we should see the PNG version of that image once it downloads. So we can open this up, and there's my PNG image. All it is did my conversion, put an S3, and all happening in parallel, orchestrated with step functions.
Great. Thanks. And of course, one of the things you saw happening there was these 3 functions executing at different rates. And while they differed by just a few seconds in the demo Rory just showed you, you can imagine very different completion rates there, more functions or fewer functions in each of those different parallel threads. And of course, maybe steps that exceed 5 minutes. And so now with step functions, you can choreograph these increasingly complex dependencies, chronologies, and different kinds of workflows together. And as some of you have asked, I'll just go ahead and answer maybe the implicit question. SWF still exists if you're a simple workflow user. Of course, we still support that product. But we wanted to make sure that we had something that was especially tailored and especially simple for serverless applications. And so we think step functions is going to be the easiest way for people to do that. And of course, we illustrated this with the console today, all available, of course, via APIs and SDKs, shall be rolled out by the end of the day. Now, we've been talking a lot about Lambda so far here, but I want to make sure that I'm also fair to the other service that I own, which is API Gateway. So I'll tell you a little bit about some of the new features that we're launching over there. First of all, just to catch everybody up, a couple of weeks ago, we launched binary encoding. Like environment variables, this one has been a much requested feature. We know that lots of companies are using different kinds of media types, audio, video, other binary files, and we're really feeling that it was challenging to translate those things into JSON in order to use API Gateway. So happy to binary encoding support here. Lets you serve images, audio, and other types of content. And we've also tried to make it as simple as possible to integrate with Lambda on the back end so that, especially if you're using that pass-through mode, we can automatically convert that into a JSON form that Lambda can process and then convert it back into binary on the way out again. So try to make that as streamlined as possible if you need to do that base 64 encode decode cycle. Now, you might have heard me talking earlier about our launch of support for documentation as part of APIs. This is obviously a missing piece, and we're really excited to get that into the API Gateway product. A couple of things to note here. First of all, that we support Swagger import and export. So you can define your documentation, and then you can load it in and export it again. We've also done an inheritance feature. So if you've got common documentation around, say, error messages or parameters, we've made it really easy to write that and then use references to it and have it kind of automatically inherit so you have less work to do as you're defining documentation. And you can still export it in completely standard Swagger if you like, or you can keep it in that inheritance format and round trip it as a special X-extension. Now, one of the things that's kind of hard to show here a little bit on screen, but we thought was really important with docs, was actually to support two different flavors of workflows. Because what we heard from customers is that sometimes the API developer is different from the person who's developing and uploading the documentation. And so we've made it possible for you to rev the docs independent of the APIs. That enables you to either set them up in different pipelines, have different people doing them, or just ensure that you're not touching any of the bits related to your API logic when you go ahead and add or increment or correct a spelling error, for example, in a documentation string. Now, the other exciting thing about Gateway is marketplace integration. So lots of people today are using Gateway to manage and simplify the process of constructing and hosting APIs. AWS Marketplace has just recently announced support for API products. And so, of course, it was very natural for us to put these two things together to make it super simple for API Gateway APIs to be hosted on the marketplace. And this helps people who are looking for your APIs easily discover what they want. They can go procure it. And then once they're using it, you need a way to track that usage and turn that back into a billing mechanism. And so that's the other part of the integration that we're launching today, is to provide that zero-touch billing support. So we automatically track the API usage. Thanks to API keys, we know who the consumer is, and we can map that back into their AWS account and send that bill to them automatically. You don't have to write any code. You don't have to generate those bills. No work at all. And this gives you a really simple way to monetize your microservices. And we're pleased to announce that 2 customers have already done just that. F-Secure, which has released their URL reputation APIs this week, and Docomo, who's released their speech understanding APIs. So customers already hopping on this. We're really excited about it, giving people that opportunity to monetize microservices and APIs very easily. Now, as part of that, you need a way to distribute API keys. And so we've also released today an open source reference implementation for a developer portal for API Gateway. It helps developers consume your APIs. It gives you a stock way of vending out API keys through user interface and with Cognito integration. And of course, it's built into that API or AWS Marketplace integration so that it would make it really simple for you to take this reference and then redirect people who are purchasing your API over to your copy of the portal. You're, of course, free to use your own. You can take this and extend it and modify it however you like. But it's a great way to get started and kind of completes that picture of setting up an AWS monetization strategy. Now, I want to hop back to Lambda here a little bit and talk about another theme here, which is new places that you can use Lambda functions. And we're constantly excited to look for other places that we can take this interesting technology and bring that simplification, that serverless methodology, that kind of agility and rapid time to market to new kinds of use cases and new kinds of scenarios. So the first one I want to talk about are bots constructed with Lambda. So you heard today about Amazon Lex, which is our new speech understanding platform. And if you've ever written an Alexa skill, this works very similarly. So you can describe the kinds of sample speech utterances that you want, indicate which parts you need to be filled in and turned into parameters. And then just like an Alexa skill, Lex will be able to turn that into a model for you and match that up to spoken or written conversations. And one particularly fun use case for that is creating intelligent chatbots. lots of companies have gotten excited about the ability to engage their customers and their users in a simple written form, whether that's through text or web-hosted chat or something that an existing application that they use like Messenger. And so Lex will be launching in preview, but with support initially for Facebook and the AWS Mobile Hub, and with Slack and Twilio integration coming soon. And we're really excited about that by giving Lambda functions as the mechanism then to implement those chatbots, take the filled out model, and then run all of the business logic, whether that's something that you want to go do in terms of an enterprise procurement, connecting to things on the back end, or a bot that you're building for maybe some other kind of social engagement, but whatever your logic is, hosting it as a Lambda function. So we're really excited about that capability and what customers are going to build with it. And one of the other things we announced this week is integration between Lambda and AWS Firehose. So in the next couple of weeks, we're going to be delivering a combination of these two things so that you can ingest huge amounts of streaming data into Firehose and route to S3, Redshift, or Elasticsearch. And along the way, have it run through a Lambda function so that you can transform, audit, aggregate, or do whatever you like with those records. And there's a flexible buffering mechanism and, of course, the built-in scalability of Firehose, which is a great match to the flexibility and auto-scalability of Lambda. And we think the two of these things together are going to provide a really amazing capability for data ingestion, as well as doing streaming types of analytics where people need to just pump a lot of data and convert that data on the fly and route to wherever their data lake is ultimately going to be. Now, in Andy's keynote, you saw our latest generation of AWS Snowballs. And lots of customers who are using Snowballs to egress data from their storage, from their existing on-prem data centers into AWS cloud storage, have asked us to make it easier for them to do things like transcode media as they place it up there, compress it in real time, do certain kinds of custom auditing that might be hard to build in for every customer. And we kind of scratched our head and we thought about that a little bit and said, it kind of sounds a lot like a Lambda function. It sounds a lot like using Lambda and S3 together. And so that's exactly what we did. We've created local replicas of Lambda and S3 that allow you to code in that same kind of programming model, but execute those functions in production inside of the Snowball as they're ingesting the data, so that you can accomplish these activities that are outside of our classic data centers, but still operating in a way and a mechanism that gives you the advantages of the serverless Lambda-based approach. And then we thought, we should go one better here. I mean, that was really useful. Maybe other people want to do this. So the other thing that we announced this week that extends Lambda is Greengrass. And it basically takes Lambda functions onto arbitrary devices so that any hardware manufacturer is able to do the same thing that we just did with the Snowball. If they have a need for very no latency, near real time, or partially or maybe even at some point completely disconnected execution, they can do that in the form of a local message broker and a Lambda function that runs right on the device. So cloud storage and compute coupled together, running essentially in an IoT setting, right, on a device, which could be a tractor driving out in a field, a ship somewhere out in the ocean, and lets you do all kinds of interesting things, become very responsive, operate obviously without connectivity, and also filter down the data, because we know a lot of that data never actually makes it into the cloud. And then when you reconnect, the data that is meaningful can be pushed back up again. And of course, you can take further and more extensive and more elaborate analysis and analytics for the part that you do want to upload to the cloud. So look for more information to come. And of course, we're launching this in preview with lots of interesting applications there. We're really excited to see where customers are going to take this. And finally, I want to tell you about Lambda at the edge. So we've already placed Lambda in lots of different data centers. And that gives customers the opportunity to execute where their storage is, close to their clients. But we also have all of these POPs, 68 points of presence and around the globe that are where we today process our CloudFront distribution as we send out storage and content. And customers have asked us to be able to take action as those events come in to CloudFront, and as we do content and origin fetches back into our data centers. And so we're excited here to take the first step of moving Lambda out into those POPs with our preview of Lambda at the edge. So initially, Node.js, 50 milliseconds of running time and just the headers, but you should expect us to start dropping the limits here and expanding the set of things that you can do with this over time. We think this is going to be a really interesting new use case, and we're excited by the prospect of low latency applications that can run extremely close to all of your client apps. So I encourage you to join the preview now and keep an eye on this for future progress. And finally, I'd be remiss if I didn't mention some of the other exciting things that are new, not necessarily from AWS, but more broadly. Serverless conferences, serverless books, courses, certifications, and of course, a large and growing partner ecosystem, building all kinds of interesting things, everything from deployment and development technologies to event integration to different kinds of code libraries. And many of those can be found on the partner site, and some of them also as blueprints in the AWS console. And of course, a large and vibrant and growing open source ecosystem as well. Our own SAM spec out there is in great company with Chalice and Apex, and of course, companies like the Serverless Framework, who are making it really easy to do local build, package, and testing for serverless functions. We're really excited to see everything that's going on out there, and especially excited by some of the stuff that we see coming up, including various kinds of big data, scientific, and numerical computing packages. We think that there are lots of interesting media types and frameworks that are about to be built here. So we have a whole day today over here in the Mirage of serverless programs and presentations for you. Wanted to call your attention to 3 that I've talked about here and that we looked at a little bit in the What's New session. At 2:30, there'll be a drill down on serverless CI/CD. So if you'd like to learn more about Sam and how he helps you do that pipeline and get your code deployed, or Weinstein will be talking about that. At 4 o'clock, we've got to drill in on bots. And so if you're interested in building chatbots and using Lambda functions to create bots, we're going to be talking about that and how it integrates with Lex for a whole hour. And finally, Tim Bray, one of our principal engineers, is going to be giving a presentation also at 2:30 on step functions. So if you're interested in choreography, larger distributed applications, and management, Tim's going to be talking all about the kind of the genesis, the thinking, the design, and showing a bunch of demos all around step functions. So I encourage you to go see more of that. And also, please join us in our serverless journey. I love tweeting about all the things that are going on in the serverless world. I promise my Twitter stream is always politics-free, and look forward to engaging with a lot of you out there in the social media world as well. I've included some useful links here also, so if you want to follow up on some of the other topics, you can do that. So please help us out with evaluations, and thank you so much.